We all work together.
Yeah, just now I spoke with him, sir.
Same college.
Thank you, Venkatesh. I have spoken to
Jagadish visited in contest international conference along with his guide.
Okay, dear baby. Thank you.
2003. In 2003.
Super, sir. Congratulations.
Live streaming is on, sir. 1 minute is there. Yeah, okay. 11 o'clock. You can start, sir. Please.
And the hospital people are behind the NCC now. Sir, we will come, sir. We will do something like that. Okay, that is one point is over. Next, tag is uploading tomorrow. Appreciated each and every stakeholder in this record. Everyone, this is all your work. So done excellently, and we are getting, because today is not more auspicious. Tomorrow we are uploading the data, and right now it is with the CEO sir for the final upload. So it is at their desk now.
Sanat sir, shall I start? Or
Vinod Soudi? Okay.
Yes, sir.
Yes, sir.
Should I start, sir?
Yeah.
Wait. Venkatesh Babu sir will address.
Just a welcome. Very good morning to all of you. I am happy to welcome all the delegates for the webinar today on the special concrete and its applications delivered by Professor Jagadish Vengala, Associate Professor of Civil Engineering, Siddhartha Institute of Technology, Vijayawada. I am very happy and honored to have him today for accepting our invitation and presenting his views on special concrete. And also it is a need of the hour for all the engineers must know. On behalf of the management of Nagarjuna College of Engineering Technology and also my department and my own, I welcome today's speaker of the webinar, Professor Jagadish Vengala. Welcome you, sir. Jagadish.
Thank you, sir. Thank you.
We are very honored to have you today to listen your expertise in the area of special concrete. You have done a lot of research, I know, especially on SCC concrete. We are thankful to you for you. And also welcome all the delegates attending throughout India. As our coordinator told, 380 registration, 100 members are watching in Zoom, and the remaining are joined the YouTube. Thank you for your support. It shows how we are interested to learn many things. And this is the subject we must aware of. Lot of development is going in concrete composites. And Professor Jagadish Vengala is one of the authority in the special concrete. Therefore, requested is readily accepted. I'll thank you once again and welcome on behalf of my department, my own, once again, all of you. Now I request the coordinator of the program, Mr. Vinod Soudi. He is assistant professor, NIT Surathkal, EDDCT, and I request him to welcome once again and all the gathering and introduce the chief guest of the webinar. Thank you.
Thank you, sir. Good morning to you all. As our beloved HOD sir introduced me, my name is Vinod Soudi, working as assistant professor in Civil Engineering Department, NCET. And I am the coordinator for this webinar titled Special Concrete and Its Applications. Vakratunda Mahakaya Surikoti Samaprabha Nirvignam Kurume Deva Sarvakaryeshu Sarvada. O Lord Ganesha, who has a huge body, curved elephant trunk, and whose brilliance is equal to billions of suns, may always remove all obstacles from my endeavors. With this shloka, I pray to Lord Ganesha to remove all the obstacles from our path. Now, it gives me an immense pleasure to welcome you all for this auspicious event. I would like to welcome the pivotal point of this gathering, who is going to enlighten us with his priceless wisdom, Dr. Jagadish Vengala, currently working as an associate professor at PVP Siddhartha Institute of Technology, Kanuru, Vijayawada. Welcome, sir. I feel honored to welcome the powerhouse and always to go kind of person of civil department, our beloved HOD, Dr. Venkatesh Babu sir. Welcome, sir. It is also my honor to welcome all the HODs and faculties from various departments and from various institutes to this webinar. Welcome to you all. Lastly, I would like to welcome all other participants from industrial background and students to this event. Welcome to you all. Now, I would like to ask for the permission from our beloved HOD sir to start this auspicious event. May I have your permission, sir?
Please introduce the chief guest of the today webinar. Please go ahead.
Yes, sir. Thank you, sir. Now, as a coordinator, I feel extremely honored to get this opportunity to introduce today's speaker, Dr. Jagadish Vengala, to you all. Before proceeding, I would like to seek the permission from Dr. Jagadish Vengala sir to give a brief introduction about him and his achievements. Dr. Vengala sir, may I have your permission, sir?
Yes, sir. Go ahead. Go ahead, sir.
Okay. Thank you, sir. Thank you. Thanks a lot. Now, Dr. Jagadish Vengala sir is currently working as an associate professor in the PVP Siddhartha Institute of Technology, Kanuru, Vijayawada. He has completed his doctorate in earthquake engineering from Vishveshwaraya Technological University, Belagavi, Karnataka, on seismic response study of bamboo-based constructions in the year 2015. He has acquired his master's degree in construction technology from BMS College of Engineering, Bengaluru in the year 2002. He has completed his BTech in civil engineering from Conuru Lakshmaya College of Engineering, Guntur, under Nagarjuna University, Andhra Pradesh. Formerly, he has worked as an HOD of civil department in BMSIT and M Bengaluru and as a scientist at Indian Plywood Industries Research and Training Institute, Bengaluru, for 11 years. He also has secured various awards and recognitions. Few of the highlights are National Governing Council member of Bamboo Society of India from 2021 to 2023, Reviewer Materials Today Proceedings for Elsewhere 2021, Reviewer Journal for Structural Engineering for American Society of Civil Engineers 2020 and 2012. He has also received various Best Paper Awards and Distinguished Professor Awards throughout his career. He has also visited Japan in 2009 as a member of damage inspection team for the world's largest 7-story wood building. He also has a patent publication on reinforced structure for preventing of auricular lobule, published in April 2020, that is last year. Congratulations, sir, for this your patent publication. He has published over 42 research papers in various national and international proceedings on various topics like concrete, bamboo structures, energy consumption, seismic studies, sustainable housing, precast technology, human hair as fibers in concrete, roof casting materials, RCC, bamboo reinforced concrete, and so on. He has also guided over 30 students in his career for their projects and has delivered over 172 lectures all over India, and so on. These are just few highlights of his 28 pages of resume. Lastly, I would just say that we are all blessed and honored and feel elated to have an opportunity to listen to you, sir, such a distinguishing personality, and shower some light upon our knowledge. Now, without stipulating the curiosity of all the participants, I request Dr. Jagadish Vengala sir to take over and enlighten us with his knowledge.
Yeah, thank you, Mr. Vinod, for giving a brief introduction about me. And thank you, Venkatesh Babu sir, head of the Department of Civil Engineering, Nagarjuna College of Engineering and Technology, Bangalore.
Yes, we have you today, sir. Thank you very much.
Sure, thank you. And I am very happy and convey my wishes to all the students of Department of Civil Engineering in Nagarjuna College of Engineering, because you have a wonderful leader who is guiding you, through the academic journey. So without delay, let me start my topic. So next 1 hour, 15 minutes, I'm going to deal with special concretes and its application. So my topic contents or some of the concretes which I'm going to highlight is starting with the self-compacting concrete, which I worked in 2000 in the year 2002, wherein I started working on this particular concrete, and other concretes like fiber reinforced concrete and some of the concretes many of the researchers are working are like translucent concrete, ultra high performance concrete, decorative, polished, stained, stamped, and 3D concrete printing. So some of the concretes I'm taking it from the literature and taking from the work from the other researchers. So to start with, I start with self-compacting concrete. Before that, I would like to show you one of the video which I have taken in a year back. Most of the time when we go through the concreting that is happening in and around, most of the time it is manually produced site mixed concrete. I'll show you this video. Please see, what is happening. The mixer operator is, putting how much ever water he would like to, and people start putting the various quantities like fine aggregate, coarse aggregate, and he has put the cement. And the video carefully, if you observe, she's putting the coarse aggregate and fine aggregate. That guy is working at the side, he's doing something else. And if you clearly see, just before, just before pouring the concrete, the lady will come and, see the mixer is moving and he's doing his work. Now you see what happens. So this lady came and she has put the coarse aggregate, and without mixing, that fellow is dumping the concrete into the concrete bucket, and that bucket is going up, and then they are placing the concrete. So can you leave the quality of concrete? You will leave it to the judgment or guesswork of the concrete mixer operator or a contractor. This is how many a times at many a places the manually produced site mixed concrete is being, what is happening in the many of the site. So what I mean to say, how to are you giving a quality to this site mixed concrete? And this is a complicated because a lot of variables are involved in making the concrete. And many of the properties will get affected, both fresh and hardened properties. You can see the pictures at various places. But slowly, over a period of time, based on the awareness levels of the customers, people moved either site batching plants or ready mix plants. So when you have to make the concrete, and somebody has to make the concrete. So this is a famous table in IS 456. We design the concrete mix based on the exposure condition, very, very important. There are 5 exposure conditions that are defined. That is mild to extreme, mild, moderate, severe, very severe, and extreme. The minimum grade of concrete for RCC is M20, and M40 is for extreme. And then the maximum water cement ratio allowed in the concrete is 0.55, and the minimum cement content per cubic meter of concrete is around 300 kgs. So if you have to design the concrete mix, you have to design based on the exposure conditions. Suppose if you are in a mild environment, if you are designing two elements like columns and then foundations. So if the column concrete, if it is a mild environment, you are designing for M20 grade of concrete. But however, the element that is the foundation, which is buried under the soil, which comes into the moderate condition. So the minimum grade of concrete you have to design is M25 grade of concrete because it comes under moderate condition. So in the same environment, the elements also it matters because the concrete element which is buried under soil comes under different exposure condition. You have to go for a minimum grade of concrete that is a different grade of concrete. With that, let me get into uh, the sum up of the normal concrete. So typically in a cement, we use the quantity between 300 to 400 kgs per cubic meter of concrete. The maximum cement content allowed is 450 kg per cubic meter as per IS 450. Beyond 450 kgs, it leads to heat of hydration, cracking, and other factors will get affected. And the maximum water cement ratio you see is 0.55 grade concrete is between M20 to M40, and IS permits you to use the mineral admixtures and chemical admixtures. Both mineral admixtures are most commonly used admixtures in India are fly ash, GGBS, silica fume, and in a little quantity, silica fume, rice ash, methacoulin, but large quantities is the most of the sites they use fly ash and GGBS. And chemical admixtures, they use the normal plasticizers to super plasticizers to retarders, accelerators, and so on. But by adding, suppose if you wanted to make the concrete flowable, so by adding merely water, more water, can you make the concrete flowable? No, because in fresh state, it leads to segregation and bleeding. And in hardened states, if it segregates and if the water bleeds, there are a lot of air pockets that create in the concrete, and in the hardened states, it gives a lot of air pockets and it leads to durability problems. So how to address this issue? How to increase the flowability? So there are chemical admixtures. We take advantage of it in our country. So the most common chemical admixtures we use are plasticizers and super plasticizers. So plasticizers are water reducers. Super plasticizers, the name itself is a high range water reducers. And we also retarders. We also use retarders and other admixtures such as air entering agents, pumping aids, shockwave aids, and other admixtures. The basic reaction of the chemical admixture, that is plasticizer. When water is added to the cement naturally flocculates. So the mixed water gets trapped inside these flocks. So to release the trapped water within these flocks, we add plasticizer or the chemical admixture such that the trapped water gets released and the workability is increased without adding more water. Suppose if you look into the example here, when you add this chemical admixture, the cement gets deflocculated and the entrapped water is released and the cement particles moves freely. You have more water is there to add it to the fresh property, and then the workability increases and even the hydration also improves. There are different mechanisms we talk about depending upon the chemical admixture. So here, one such mechanism is interparticle repulsion. It creates a different charges on the particles, and the cement particles will get separated by adding the chemical admixture, and the water gets trapped inside these flocks, get released. That's how the more water is available for the workability. You can see the difference between the flocculated and deflocculated cement particles after adding scooplasses. This is a microscopic picture you can see. So what we can do by adding the chemical admixture or the plasticizer, you can do two things by adding the plasticizer or the chemical admixture. So one is you can increase the slump without changing the water cement ratio. So in the first case, you have like 0.55 is the water cement ratio, 75 mm is the slump, 51 MPa is your strength. Without changing water cement ratio, you have added the chemical admixture so that the slump increased from 75 to 180 mm in the first case. In the second case, we have maintained the same slump. By adding chemical admixture, you have reduced the water cement ratio such that for the reduced water cement ratio, you got the more strength, that is 63 MPa from 51 MPa. So by changing the water cement ratio or maintaining the water cement ratio, either you can get this lump or you can get the strength. But when you're placing the concrete in the reinforcement, usually we call it as a free fall height of the concrete. As per IS, it should be 1.5 meters. Suppose if you are placing the normal concrete, what happens? The mortar gets stick to the reinforcement, and the other particles like sand and particularly the coarse aggregate particles get separated out. Only the mortar gets stick to the steel, particularly in the congested reinforcement. So this is the common segregation we observe in many of the sites. So you need a flowable concrete to place it in the congested reinforcement. At the same time, it has to flow. So how do you achieve the flowable concrete without segregation or bleeding? By adding more fines. So you cannot use the more cement so that you cannot increase the you cannot use beyond 450 kgs of cement because you need more powder to flow the mix. So by incorporating fines, you can impart corrosion in the mix and you can enhance the ball bearing effect. That means the workability of the concrete. And RMC is there, and concrete pumping, the advanced methods. But we have a large and complex structures are coming up in India, and people are using it. There is a lot of congested structural reinforcement. Then vibration is a question mark in many of the sites. So these are the kind of congested structural reinforcement you can see, particularly for the special structures. This is one of the picture from the Japan nuclear silo. And you can see even the congested structural reinforcement in, this is a Delhi Metro Rail DMRCL work. So what is the solution? What kind of concrete you have to put in? So you have to place the concrete, which is highly flowable, and it should be stable all the time, and it should readily place it in and fill it into the entire formwork without any vibration, without any consolidation, and also at the same time, it should not get separated. So that concrete is nothing but self-compacting concrete. So where it is originated, there is a skilled workers problem in Japanese industry in late 1980s, 1990 and so on. So the motivation behind SCC origin is the gradual reduction in skilled workers in Japanese construction industry. So the work was started at University of Tokyo by Okamura and all. And there are a lot of advantages, particularly self-compacting concrete. It will shorten the concreting period. It will minimize the voids. No need to vibrate. It will avoid honeycombing. It will eliminate the compaction using the vibrator and so on. How the properties are different from the normal concrete. Normal concrete, the powder content is between 300 to 450 kg per cubic meter. But in case of SCC, the powder content varies between 450 kg per cubic meter to 600 kg per cubic meter. So the minimum itself is 450 up to 600 kg is the powder content. Normal concrete, if you take generally a normal mix of M20 grade, if you take the fine aggregate varies between 700 to 800 kg per cubic meter, and coarse aggregate varies between 1200 to 1400 kg per cubic meter. But in case of SCC, lower coarse to fine aggregate ratio. That means both coarse and fine aggregate are in equal quantities, or sometimes the coarse aggregate is lesser, lower quantity when compared with the fine aggregate. And superplasticizers and segregation control admixtures are used in making SCC. As I mentioned, it requires a 450 to 600 kg per cubic meter. You cannot use cement alone because ISAs use more than 450 kg per cubic meter. There are problems like heat of hydration, drying shrinkage, creep will increase. So you have to look for the other materials. And this powder content will make the coarse aggregates in suspension during the flow. And also it will give a lot of cohesiveness to the concrete. So beyond 450 kg, you have to use the powder content in SCC. So you have to look for the other powders. As IS 456 class 5.2 allows you to use number of mineral admixtures, as I mentioned, starting from fly ash, GGBS, alcofines, microsilica, meticulin, rices, cash, so on. What if you add mineral admixture? You know the basic reaction. When you add water to the cement, the basic hydration process will happen. The final product, what we call is calcium silicate hydrate, that is CSH gel, which gives strength to the concrete. And there is a remaining amount of calcium hydroxide or Portlandite, we call it as. Suppose if you add secondary cementitious material or secondary cementitious material, the excess lime, whatever is present in the concrete, it will react with supplementary cementitious material, whether you add fly ash or GGBS, whatever. And again, the secondary reaction will happen and it form more CSH gels in the concrete. That means the excess lime that is present will get reacted again with supplementary cementitious material and more CSH gels. That means more dense the concrete, more strength you will get. This is the typical hydration process, and if you add pozzolan, it will increase the impermeability and it will increase the strength because the pores will get filled with the additional CSH gels. And also it will increase the compression and tensile strength because you have a less bleed pockets and a more dense hydrated cement paste in the concrete with the pozzolans. So we call fly ash is the ideal material because India generates more than 100 million tons of fly ash annually. We have a more thermal power stations, number of thermal power stations. So right now I'm in Vijayawada, we have Vijayawada thermal power station and in Raichur thermal power station in Karnataka, Mettur. There are a lot of thermal power stations all over India, which generates, because electricity, the major generation of electricity is from thermal power plants. When compared with the other supplementary cementitious materials, fly ash is availability is more. And when you look into the particle nature, these particles are typically spherical, and the diameter is less than 1 micrometer to 150 micrometers. And we have a more availability of dry fly ash from ESPs, that is electrostatic precipitators. This is how the morphology looks, the smooth, glassy nature. That's how you get the ball bearing effect in the concrete, in the particularly the fresh properties. This I have already explained. When you add any supplementary cementitious material, secondary reaction happens, and that's how you get more CSH gels, and it imparts strength to the concrete. When you compare with the other materials like silica, fume, or metacaolin, so it is a low cost. You need to spend cost on transportation. And you can use the amount also, the more in quantity, like 150 to 350 kg per cubic meter you can use. That's why we call fly ash as ideal powder. Coming to the properties of the self-compacting concrete, normal concrete generally you do only slump test, typically at sites and other tests. But SCC you need to test it. It's three properties, that is a filling ability, stability, and passing ability. Filling ability is the ability of the concrete to flow and fill completely all spaces under its own weight. And the passing ability is the SCC, whatever you have poured onto the element, so within the formwork, it has to flow through. We have a reinforcement, it has to flow through the tight openings of the reinforcement. So while flowing, there should not be any segregation or blocking of aggregate should not happen. So that's how the property passing ability test, it has to pass. I'll show you what kind of test you do it on SCC. Next is segregation resistance. It should remain homogeneous throughout. After mixing, while transporting, and while placing, it should be homogeneous in composition. Very important. Some of the test methods we use are slump flow, and there is a T50 centimeter slump flow, so which measures filling ability. Similarly, jeering, V-funnel. V-funnel, you do two tests. One is V-funnel at 0 minutes and V-funnel at 5 minutes. And we do L-box test, U-box test, fill box test. These are all, you see, passing ability. And you have a GTM screen stability test and Ormit test. Okay, some of the tests I'll show you now. You know the slump cone, this is a slump test I'm going to explain. Normally for normal concrete, you place the concrete 3 layers, each layer 25 times you tamp and then you lift the slump cone. You measure the vertical slump in case of the normal concrete. But in case of self-compacting concrete, because it flows, you have to measure the horizontal spread. So once you lift the slump cone, it spreads. So you have to measure the horizontal free flow. The range of the spread should be between 600 to 800 mm. So once you lift, the concrete flows. So this is how you measure. There is also one more measurement we do for self-compacting concrete. That is the time taken to reach the concrete to a diameter of 500 mm. So once you lift the cone, because you know the cone size, right? The bottom is 200 mm, top is 100 mm, the height is 300 mm. So when you lift the 200 mm bottom slump cone, the 200 mm should, it spreads. So the time taken to reach from 200 mm to 500 mm, we measure that, we call it as a T50 centimeter time. It should be between 2 to 5 seconds. This, so you should not place the concrete and tamp it like normal concrete. You just have to pour the concrete once you mix it, and after pouring, sorry, yeah, after pouring, you just have to uh, lift the slump cone. This is how it spreads. You can even measure the T50 centimeter slump flow. And what is the total horizontal spread the concrete has taken? And this you can also observe, is there any segregation or bleeding is there in the mix, whatever you have taken. This is how you measure the slump flow. Next test is V-funnel test. These are the dimensions of the V-funnel. You'll assess the flowability of fresh concrete. Most of the times, these V-type funnels, we measure the viscosity of the fluids. You might have seen in chemistry. Okay, many of the viscous fluids. We measure the viscosity through V-funnels. So, like that, these are the dimensions of the V-funnel. You place the concrete in the V-funnel. You measure the time taken for concrete to flow through the narrow end is measured. So that is the V-funnel time. The recommended values are between 8 to 12 seconds, 3 to 12 seconds, basically. So this was the initial V-funnel I made in way back in 2002. This is this particular V-funnel. So this is a V-funnel. And there is one more measurement you do using the V-funnel, that is V5 minutes flow time. How you do? You place the concrete in the V-funnel. You have to wait for 5 minutes. After 5 minutes, you open the bottom door. Then you measure. What happens when you place the concrete and wait for 5 minutes? The mix is not good. All the coarse aggregate get collected or get settled at the narrow end. So when you open the gate, it will slowly, pass through the narrow end, because if the concrete is not good. So the recommended value says maximum. It should be less than plus 3 seconds. That means V-funnel time, if you get 8 seconds, V5 minutes flow time, it should be 8 plus 3. That is less than 11 seconds. You should get V5 minutes flow time. This is how you can see the video. You just have to pour the SCC onto the V-funnel. And you have to ready with your stopwatch time. And you have to remove the bottom door, pull the bottom door, and then measure what is the V funnel time. Similarly, you can measure, you wait for 5 minutes and you can measure V5 minutes flow time also. Next test is L-box test. In L-box test, you have two boxes. One is vertical and another one is horizontal box. So here you measure the passingability of fresh concrete. So there is a gate, small gate, consists of reinforcement. So the concrete should pass through this reinforcement. So here you measure two things. You can measure the time taken to reach 200 mm and 400 mm horizontal box dimension. Our total horizontal box dimension is around 700 mm. So you measure from the vertical box. You can measure the time taken to reach at 200 and time taken to reach at 400. The recommended value is also there. But what you measure is the blocking ratio of the concrete. So once you fill the concrete in the vertical box, you lift the gate. The concrete has to flow through this reinforcement, and you measure the heights in both ends. And the height the ratio between both the heights will give you the blocking ratio. So it should be greater than or equal to 0.8. It should be more than 0.8. If it is less than 0.8 means, there is a problem with the mix. So this is how you measure the fill box, the small video. So once it is filled, you lift the gate and there is a reinforcement. So it passes through the reinforcement. You measure both the ends, what is the height, and the ratio between both the heights will give you the blocking ratio, that is H2 by H1. There is also a measurement that is called U-box test. This also measures the passing ability, just like L-box. You fill one limb of the U-box with the SCC, and then you will open the gate and it will pass through the reinforcement, which is placed at the middle, and then the concrete comes into the another limb. So you measure the difference, height difference in the two limbs. It should be less than 30 mm. This is how you measure. So one of the limb, you are filling it using SCC. So while filling, the gate is closed. There is an abstraction between the one limb to another limb. Once you pour the SCC, you lift the gate, middle gate, you can see the concrete flow through the reinforcement and comes to the another limb. Then you measure the height difference between these two limbs. You can see here. So this is here and here. The height difference should be less than 30 mm. That's how you measure. Next, there is also a test called Jeering Test. So this is a simple test. You measure the filling ability and a little bit of passing ability. You have a ring with the reinforcement. At the middle, you place the slump cone. You pour the concrete, you lift the slump cone. And the concrete also passes through this jeering. So you measure the height difference between inside jeering and outside jeering, because it passes through the reinforcement. If the mix is having a problem, so you found more height in the middle because it won't pass through. So the height difference between inside and outside of the jeering should be less than 10 mm. This is how we measure the jeering test. Next is fill box test. Initially, we also made a fill box, a box to test initially. I'm talking about 2002. So the box, you fill it using SCC, and it should flow through these reinforcement, and it should fill. That means it should fill between 90 to 100%. How it is, you can see here. One side you are pouring the SCC, and it is passing through the obstacles, the congested obstacles we created. And the filling percentage should be 90 to 100%. You can see here. It should be completely filled. If the concrete is good, the value will be between 90 to 100%. So this is a fill box test. Next is, there is a test called GTM screen stability test. This is a very simple test. You take a 10 liters of concrete in a bucket, wait for 15 minutes, then half of the top quantity, that means the top 5 liters quantity, you sieve it through 4.75 mmC. Then you measure the the mortar that passes through 4.75 mmC, because all the mortar will get passed through the 4.75 mmC to the original sample taken, that is the 5 liters sample. You take the percentage, that is actually that percentage should be between 5 to 15%, because you should have a sufficient quantity of coarse aggregate particles in the top layer of the 5 liters, because if there is a problem in the mix, the aggregate particles will get settled down at the under the bottom of the bucket. Okay. So the segregation resistance, what we call, it should be between 5 to 15%. So when you sum up all the tests and the values, the slump flow should be between 600 to 800, and the values changes from code to code and country to country, but these are the typical values initially it was proposed. And you might get a confusion like, what are the combination of tests we can use it for acceptance? Japanese, they use a slump flow V funnel and U-box test for the acceptance. And Sweden, they use slump flow and L-box, because L-box you get a passing ability, and slump flow you can measure the filling ability. And Jeering and U-box, some of the other countries they follow. And we actually suggest like slump flow, either U-box or L-box. And you can measure the V funnel at 5 minutes. That also gives a very good indication of the segregation resistance. And coming to this, some of the applications of self-compacting concrete, this is the Osaka gas station. This is the first application of SEC. This was done in 97, 98. You can see the inside view of this particular gas station, wherein this complete structure is made using the self-compacting concrete. This is Akashi Kaiko Strike Bridge. I happened to go there and took a picture when I visited Japan in 2009. So this particular bridge was opened in 98, and this is the longest suspension bridge. It connects 2 islands of the Japan. The length is around 3.9 kilometers. The 240,000 cubic meter of SEC is placed in this particular tier. And the limit, then a lot of applications, people are now using regularly this self-compacting concrete. DMRC Delhi, they've used self-compacting concrete for their tunnel lining and so on. And some of the applications in Sweden for tunnel lining. And precast concrete elements in Netherlands. Precast elements is a very good example of using SCC. These are the precast elements. You can just lift it. For precast applications, SCC is quite useful. This is one of the commercial center in Italy, almost 2,900 cubic meters of concrete volume. And the work completed, it started in January, and October, the commercial center got completed because of the speed of SCC. And some of the prefab benches in Spain, and Dr. Ravindra Getu worked on this particular concrete during that time at University of D. Catalina, Spain. Ravindra Getu is a very good friend of Dr. Venkatesh Babu. So these are the benches they made, and they used the SCC for application. These are the benches you can see. So when we worked in 2002, these are some of the experiments I would like to mention. So we used OPC 50 grade, and during that time I was in Bangalore working for Torch Steel Research Foundation, India, wherein we have brought the Raichur Thermal Power Station fly ash, and wherein the Blaine's fineness is 4,770 centimeters square per gram. We used 12 mm down, and river sand we used. That time natural river sand is available. Now in Bangalore, most of the sites are using manufactured sand, crusher fines. And we've used that time polycarboxyl PC based classes and VM. These are some of the initial mixes what I did. Cement is around 430 kgs. And you can see the coarse aggregate content is lower than the fine aggregate. 650 is coarse aggregate and 840. And the bottom mixes you can see, the bottom 4 mixes, that is SCC. We arrived from a normal mix to SCC. And the fly ash we've used around 160 kgs. These are the slump flow values. You can see the bottom mixes. PFNL we got around 3 to 4 seconds. And the L-box blocking ratio is more than 0.8, and then GTM segregation ratio is between 5 to 15. Very interesting results, which was presented in, as Venkatesh Babu was mentioning. This I presented in 2003 in one of the international conference conducted by Kumar Guru in association with Ravindra Gateway. So the interesting work here is we used fly ash and we tested out of curiosity 180 days and 270 days of the performance of SCC. 28 days we got around 50 MPa, but 270 days we almost got 90 MPa strength. Almost 70% more strength when compared with the 28 days strength. So all the cubes, whatever we have made, made, we just pour the SCC into the molds. So based on the number of experiments conducted by various researchers, it is very evident that SCC is, the hardening properties of SCC, when you look, is equal or higher compressive strength many times. And it's a same or greater resistance in terms of freeze-dry. And all the, it improves durability because of the less voids in the concrete. And SCC mixes, particularly, having high paste contents. In normal concretes, typically you have this powder content is around 26, 27, 28%. But in case of SCC mixes, the powder content goes up to 38 to 45% when you look into the volume fraction of the paste. And as I mentioned, the coarse and fine aggregates having equal volumes. But anyway, whatever mix you make should need guidelines, laboratory tests, and field trials. Very, very important. So with that, I'm moving to the next concrete. Here afterwards, I will little move quickly because it is already 11:50. Maybe I'll take another half an hour, okay, or half an hour to 40 minutes. So next concrete I'm going to discuss is about fiber reinforced concrete. Why we use fibers? You need to bridge the cracks and also increase the ductility in the concrete elements. And also there is a considerable improvement in the post-cracking behavior after using the fibers. And it will reduce the permeability, and some fibers even it will increase the abrasion and shatter resistance. A typical graph between stress strain curve with a plane and FRC with low fiber and FRC with high fiber volume. You can see the stress strain behavior. With fibers and without fibers, it will, it will add. The fibers will add to the, the cracking behavior. It will arrest the cracking behavior of the concrete. A lot of fibers are available, number of fibers, types of fibers, steel, glass fibers, and you have carbon and cellulose fibers. You have a synthetic fibers, even people are using polypropylene fibers and nylon fibers. So initially, we tried Recron 3 years Reliance fibers when I was in Tostil. I'm talking about 2003, and during that time, that was the first time we tested the fibers for various concrete applications. And natural fibers like coir, hay, even the bamboo fibers you can look. Some of the properties of these fibers you can look. Some having more Young's modulus, some having more ultimate elongation, some having more tensile strength. But what are the factors that affects the properties of FRC? We should know. One is the volume of fibers. How much volume you increase? Is it like low volume, medium, moderate volume, or high volume? you're using, it affects the properties. And also the aspect ratio and of orientation. Coming to the volume of fibers, if you're using less than 1% of material fibers, we call it as a low volume fraction. Usually we use it for horizontal applications, particularly slab and pavement exposed surfaces, horizontal exposed surfaces. 1 to 2% we use it for the moderate volume, that is, we call it as a moderate volume. And we use it for shotcrete applications because when you do the shotcreting, it has to go and stick to the reinforcement. It has to go and stick to the reinforcement, and the mortar or the material should be together. So these fibers you need more fibers, and it will also improve against the capacity against delamination and spalling because it holds the materials together, these fibers. And high volume applications, particularly for high performance fiber reinforced composites, we use high volume fractions, like more than 2% by volume. Aspect ratio is also very important parameter. That is the length to diameter ratio of the single fiber. When you look into the aspect ratio to relative strength, up to 0 to 75 aspect ratio, there is an increase in the strength and toughness. But beyond 75, there is a decrease again. So you have to use the fibers between 0 to 75. Okay, the aspect ratio, L by D ratio. Orientation, how do you orient? Like, is it direction of load or direction perpendicular to load or randomly distributed fibers? But general concrete applications, we usually distribute randomly. But when you observe, fibers aligned parallel to applied load offer more tensile strength. So when you place fibers, particularly for special applications, so you get a more strength and toughness when compared with the randomly distributed or perpendicular. And the low modulus fibers imparts more energy absorption when compared with the high module fibers. Low modules are like nylons, polypropylene. High modules are steel, glass, or carbon fibers. This is very, very, very important. Many times people will miss this. The mixing sequence, when you are making fiber reinforced concrete, you have to be very careful. You have to be very, alert. Listen, many they don't follow it. They dump everything: cement, coarse aggregate, fine aggregate, fibers at one shot, including water, and then they mix it. But in case of the fiber reinforced concrete, when you're making this concrete, this is very important. First, you have to place half the coarse aggregates and put 20% of fibers and mix it. Again, remaining half the coarse aggregates and another 20% of fibers and mix it. Then again 50% of sand, put 20% fibers, mix it. Again 50% sand and again 20% fibers, mix it. Then lastly put the cement and rotate, and lastly remaining 20% of fibers and add water at last and then mix it and place it. This is a mixing sequence you have to follow because the fibers has to be distributed randomly. If you don't do it, the fibers, the lump of fibers will somewhere it will get settled. Many applications in India and abroad, Heathrow Airport, the road project in Madura, and many of the applications. So we did some work coming to some of the work we did. We did a fiber reinforced SCC with the ternary blend we did for one of the projects. We did trials. So we used a cement of 350 kgs and the GGBS we used here 135 kgs, and because it is the concrete is a high strength concrete, we use alco fines and silica fume also. So this is without fibers, around 69 ampere we got. So we made a SCC mix and we did all compression, weave funnel, slump flow, box test. These are the mixes you can see here. The first mix, the 28-day strength, you can see 56 ampere with 25% GGBS. And then next 20%, and then we got 25% is more strength, so we use 25% and 10% alcofines we use. 15% alcofines, 10% got optimum, so we used again 10% and we used 6% and 8% silica fume. Out of these 6% silica fume, we got optimal mix. So this mix 5 we have taken an optimal mix with the various powders, SEC. Then we started adding the fibers at different quantities. This is 0.3 fibers, with and without. There is a compressive strength, the more or less same. 1 MPa is not a great difference. And you can see the flexural strength, we got with fiber almost 1 MPa difference. 1 MPa in flexural strength is more. So there is a lot of improvement in flexural strength while using the fibers. Again, with and without fibers, of split tensile strength. Here also you can see the great difference, almost 1 MPa. Next, so you can see the difference between the with and without fibers, the flow difference. Very important, when you add the fibers, more surface area is involved and the flow automatically reduces. That means there is a little dip in the flow. You can see both in L box, V funnel, and slump. So in slump flow itself, spread is because of the fibers, the spread drops down to 40 mm. And based on the review of literature or based on various works, typically polypropylene and steel fibers when used, these are the results, particularly on compressive strength. You can see it holds, even the fracture behavior of the concrete also you can see when you use the fibers. Even the tensile strength also, it holds. The crack behavior, it changes completely. The impact strength, so it holds the concrete into place. So it is more, if you use the fibers, it also contributes to the impact strength. Shear strength. Some of the applications like Terry Dam in Uttarakhand. So coming to the next concrete, that is lightweight concrete. Lightweight concrete, the density is between 300 to 1850 kg. Normal concrete, you know that it is between 2200 to 2400 kg per cubic meter, but we take generally 2400 kg per cubic meter as a normal concrete density. So it is up to 2600 kg. There are 3 types of lightweight concrete you can produce using the aggregate, using the lightweight aggregate. And you can aerate the concrete and you can remove the coarse aggregate. That means, remove the fine aggregate. That means no fines concrete, only aggregate and paste. So in between you can create the voids. Lightweight aggregate concrete, usually UK, France and USA, the applications are generally they use the lightweight aggregate concrete. In Scandinavian countries, they use aerated concrete. No fines concrete is a little less popular when compared to the other. This is the work we did for one of the project in Vijayawada. When they wanted to go for a lightweight slab roof for a clubhouse, so we used the EPS beads as coarse aggregates, and we could able to reduce the density from 2400 kg per cubic meter to 1200 to 1500 kg per cubic meter with a compressive strength of 10 MPa, because they want a little less. This is only for minor applications. So we used EPS beads as aggregates and reduced the density and got the required strength also. There is also a structural lightweight concrete, we call it as. So here, the condition is minimum 17 MPa strength you should have, and dry density should not exceed 1850, less than 1850 kg. And aerated concrete, AC block is one example for aerated concrete. So you can induce the air in 2 ways. One is by incorporating gas. This gas is produced by incorporating aluminum powder into the concrete mix, wherein it is a gas producing agent. you take a 0.2% by weight of cement. How it reacts, the aluminum powder reacts with the COH twice, and it will liberates hydrogen bubbles. That's how you can create the voids in the concrete. That's how the density will get reduced. You can see the AAC, autoclaved direct concrete block, is such an example. You can see the surface texture of the AAC block. AAC block, one of the project I did with, we did with Ultratech cement, and we did some experiments wherein the block density is around 650 kg per cubic meter. And when compared to the solid concrete blocks, the temperature you can reduce. There are like 2 to 3 degrees centigrade less temperature when compared with the solid concrete blocks. Next is pervious concrete. So wherein no fines concrete, you can call it as. You will allow the water. In other cases, we don't allow the water. Here you allow the concrete, allow the water. So you design the concrete based on the water drainage rate per minute in a 1 square meter area, how much amount of water you will allow. So the range is between 320 to 120 liters. The density also between 1600 to 200 kg. A lot of applications, particularly residential roads, driveways, swimming pool decks, and so on, wherein once the rain comes and it won't stagnate, it passes through the pervious concrete and it joins with the nearby drainage system. Next, there are a lot of concretes that are used for specialized applications, smart concrete, particularly conductive concrete. This is basically a heating concrete. So here, for this concrete, use a 2% steel fibers and 20% steel shavings. Almost 22% of steel you use it inside the concrete. So what you do, you will plug that concrete to a power source. It will get heated up. What is that? The steel shavings inside the concrete. These are particularly useful for the cold countries wherein if you wanted to de-ice the concrete surface. So, you heat the steel shavings, you heat the concrete such that all the icing will get de-watered. The de-icing purpose you do it. And per square meter, it seems like 10 to 40 kilowatt hour the power it consumes. There is a pressure sensitive concrete. When you use the carbon fibers, 2 to 3%. So you can actually monitor the load of bridges and highway pavements. And there is a self-curing concrete, wherein either you can use a lightweight aggregate, wherein it holds the water inside and slowly it migrates. This water migrates to the cement paste. The hydration keep happens. And ultra high performance concrete and reactive powder concrete, special applications, lot of combination of materials, so the composite materials you use. Silica from quartz floor, fine silica sand, water reducer, various fibers. This is the difference between the high performance SCC to ultra high performance. So you can see here in case of reactive powder concrete, there is no coarse aggregate present. In ultra high performance concrete, you can see around only 32%. Even SCC also you can see. This ultra high performance concrete or the reactive powder concrete is used for a specialized application, particularly architectural curves or whatever the shapes. If you want, you can use this kind of concrete. And it can produce up to 200 MPa of compressive strength and 20 MPa up to flexural strength. And there is a high density concrete. This concrete, we use it for radiation shielding. Some of the aggregates we use it for this high density concrete is barite or magnetite. The density goes up to up to 3,360. Some concretes using iron, you can go up to 5,200 kg. High performance concrete is a combination of different concretes. Particularly, it has to satisfy both performance and uniformity requirements. And high performance concrete, the permeability factor, and you have a lot of you have to take a lot of proportioning methods, and you have to take care of the moisture, vaporized gases, dissolved ions. So what I mean to say is the permeability factor and also durability factors you have to consider in case of high performance concrete. Some of the salient features: compressive strength is more than 70 MPa, very high release strength, and high degree of impermeability, and also high resistance to sulfate attack. And it should have the smooth fractured surface in case of the high performance concrete, and also high levels of corrosion resistance. So both the performance and strength, durability requirements. High density concrete, I've already mentioned the applications, particularly the radiation shields and so on. You know that there are typical radiations, electromagnetic waves, and nuclear particles. So you should have an appropriate thickness of concrete sheet to arrest these rays. And also high temperature is generated. So aggregates whose specific gravity is more than 3.5 is used for particularly high density concrete applications. Some of the aggregates are like barite, magnetite, ilmenite, so on. Should be highly dense and appropriate admixture and vibration. For good compaction, you have to go. Recently, you know, you're hearing even the in the news channel, you hear about 3D concrete printing. IIT Chennai has done a lot of work, particularly on 3D concrete printing. It's a computer-controlled sequential laying of the concrete material. There are different methods of 3D printing. One is a robotic arm-based and a frame-based systems when you are talking about extrusion-based 3D printing. And also there is a binder jetting. You can see the video. So this is a picture printing of concrete, printing of cone by 3D concrete. I'm just skipping. This is the house. So layers of concrete is placed. So we have to check the viscosity. Once the concrete comes out of the jet, you have to, it has to place and set immediately. So you have to work a lot on this particular concrete. So there are two types basically. One is mobile 3D concrete printing, wherein it can be used in multiple locations. You can take it. So robotic arm sits on a rubber truck, and then it moves, you know, regardless of terrain. So the motor comes out from the hose, and then it prints in the program location. And there is a fixed 3D concrete printers, which are useful for precast applications, particularly universities, research institutes. For prototyping and precast production, it is used. So it is a fixed one. Robotic arm sits at a metal frame, and motor comes out of the same jet. There are some of the other concretes, that is translucent concrete, wherein using glass fibers, acrylic rods, and optical fibers. So it will allow the light to pass through partially. You can see the video, small video. You can see the other side. So using acrylic fibers. Next is a bendable concrete. University of Michigan, they developed a fiber reinforced bendable concrete, wherein you use the engineered cementitious composites, plus of course aggregates, using fibers and other. And it is a 40% lighter, 500 times more resistance to cracking. You can see a small video of this. So you can see the conventional concrete and bendable concrete, the difference for the same load. Next is decorative concrete. So using the pigment in the concrete, and you can make the concrete. Some of the work I've taken from Ultratech. This is a polished concrete. So you can polish the concrete after being placed so that you can get a nice finish. Stain concrete. You can do the acid etch staining. Ultratech is doing this work. You can make concrete sinks and vessels using the concrete. Stamped concrete, very simple. So in a fresh state, you place the required shape. You stamp it on the freshly placed concrete, and then you get the desired texture, basically. That's how we call it a stamp. So these are some of the references. Thank you. Maybe I've taken a little more time. Yeah.
Thank you, sir, for such a
Over to the
wonderful presentation. Now I request participants.
They can ask the questions. Participants, if they want, they can unmute themselves and they can ask the questions.
Hello. Sharath?
Sir?
I am audible?
Yes, sir.
Yeah. Presentation is over, no?
Yes, sir.
Thank you, Professor. You have presented as justified the topic as special concrete and applications. You have given a lot of inputs with respect to mix design and mixing aspect. See, the mixing is very important. Hello, madam. Yeah, you are rightly mentioned. The strength of the concrete depends upon 28 parameter. Many of us, we are not taking control of that. Therefore, the strength is deviating. And FRC especially, I'm seeing that you have presented the mixing sequence, mixing time is very important. I hope that all the delegates benefited with this presentation. And we are very happy to have you today, and you justified the topic. And on behalf of management, my own department, I'll thank you once again for your time and preparing all the materials and taking your time for presentation. Now I request any questions are there. We'll take Hello. And also I'm happy to welcome Dr. Praveen Agarwal from NIT Jaipur. Praveen? Professor Praveen.
Yes, sir. Good afternoon.
Please.
It is very good to hear Dr. Jagadish Vengala, whose paper on SCC I referred in. He published the first paper on SCC in August 2003, Indian Concrete Journal. I remember that paper very well. And of course, Dr. Babu, I remember you. And
thank you for joining, Professor, from NIT Jaipur. I'm very happy.
I am presently at RTU Kota, Rajasthan Technical University, Kota.
Oh, nice to hear, sir. Thank you.
Dr. Praveen sir, thank you so much. And Dr. Praveen sir also worked a lot on self-compacting concrete during that time. And his work is very well noted in Indian Concrete Journal also. Thank you, sir. Thank you.
Yeah,
So
Dr. V. Selvam from Coimbatore.
Thank you, sir.
Any questions from your side? Selvam?
Sir, one question is there.
Yeah.
Which type of fiber is used in translucent or blended concrete or in other fiber used concrete?
yeah, in translucent concrete, we use a mix of glass fibers and basically acrylic rods, optical fiber rods we use in particularly in translucent concrete. And bendable concrete, people are trying different fibers because mixing with different constants, wherein at the same time you have to, maintain the strength and you have to make sure that cracking should not appear. So the combination of fibers, various fibers they've used in particularly the bendable concrete.
Hello, sir. May I?
Yes, sir. Please go ahead.
My name is Ajit Kumar. Sir, it was an excellent presentation. Really enjoyed your covered lot of aspects of the concrete, different types of concrete. But during your presentation, I missed the self-healing concrete. Can you just say something about self-healing concrete?
Yeah, the self-healing concrete is, there are like a self-curing concrete or self-healing concrete is like a bacteria concrete. So people are trying with different microorganisms wherein they induce in the concrete. So if any of the cracks that appear in future, these organisms automatically react with the line present in the cement and it fill the cracks. So that is what the self-healing concrete. I am not present there, sir. Yeah.
Okay. Sir, also you talked about Pervious Concrete, which is a very good remedy for the urban, which will help us also in rainwater harvesting, also conserve water. But there is I don't know whether it's a myth or it is that over a period it gets blocked.
Yeah.
Collection.
Yes, sir. You are right. That is why you have to do a study, like, what kind of, the water flow is there per year. And accordingly, you have to design the pore sizes and also the drainage rate. So with that, you have to design the mix.
But
so
anywhere in the world which is successfully in place, and what kind of how long, how old that concrete is done across the world? Any references?
Yes, sir. There are a lot of references. Definitely, I can send it to you.
Okay. Thank you, sir. Thank you very much.
Sir, one more question is there. Reactive powder concrete is having 1 minute. It went somewhere. Having more compression strength.
Yeah, reactive powder concrete, you can make concrete up to 200 MPa strength. Yes, you can.
In what application powder concrete is used? The same person has asked.
Okay, particularly the applications, special applications like architectural applications. Suppose if you want to make some curves or something like that, you can just have to pour it to the required shape. And because thin elements, particularly thin element applications, you need a more strength because if it breaks, it is a problem. So for particularly thin elements, we go for the reactive powder concrete. Very limited applications, but you can definitely produce a strength of 200.
Any more questions? You can post or you can directly unmute and you can ask. Feedback link is already given. For students, one request is today evening, one more webinar is there. You can join for that also. Yes, sir. Vinod, sir.
I have one more question.
Okay.
Yeah, in concrete industry, the biggest problem we are facing is the cracking, because lot extensively RMC has been used, and the plastic shrinkage cracks are becoming a big problem, and which is creating a lot of water leakage issues also. How can you address this, sir?
Yeah, because when I worked in Tall Steel, I used to go to different RMC plants, and I used to attend some of the projects, like going to batching plants and fine tuning the mixes. It's very important to sensitize, particularly the workers in the plant, particularly site batching plants, and because they don't understand the sensitivity of the water content. And whenever the batch changes, most of the time they go for the same mix. The batch of the coarse, either the coarse aggregate or the fine aggregates. And fibers is one option you can analyze the concrete, and also the powder content. And the powder content, if you are using particularly mineral admixture, either fly ash or GGBS, when you are also using the chemical admixture, you need to find the compatibility between the chemical admixture and the mineral admixture and the cement also. Because there are a lot of compatibility issues. It has to be sorted out. Because when you buy or when you purchase the chemical admixture from a client, so either for a new client or the old client, so you have to find out the solid content in the chemical admixture and the dosage, how much you are adding, and whether is it compatible with the powder, that is both cement and the admixture, mineral admixture, and to fine tune accordingly. Because many times some of the cements are not compatible with some of the chemical admixtures. It may give problem. And sometimes when you are using fly ash or any GGBS, there are setting problems, and as you rightly mentioned, shrinkage problems and other things. So these things has to be sorted out before we are actually placing the concrete. But when we are working commercially, we don't have time to. So that is why educational institutions has to come forward and sort out these small issues, because they don't charge much, or otherwise you have to keep on sending the samples of the materials to the nearby institutes and get it tested. Because a lot of projects, BTech or MTech projects, they are doing, supply the materials and find out these compatibility issues, there is any problem. So that's what I closely associated in Bangalore RMC industries and so on. Yeah, this is what I can say, sir.
Thank you, sir.
There's
Thank you.
one more question, sir.
Okay. Please.
Organic fiber is used in concrete or not, sir? And the same person asking, sisal, coconut coir, and bamboo are used in it, sir?
Yeah, there are a lot of examples of sisal and coconut coir and bamboo is being used in concrete. Bamboo being one of my the major research topic. So there is a usage of these materials in terms of fibers. At the same time, in terms of the material itself, material in the sense of different splits or slivers. Okay. It is used in the concrete. So it all depends on, again, application to application. Only thing is you have to treat these materials, because these are all, over a period of time, because it is a biological based material, biomaterials, you have to treat it. Generally, we treat like bamboo using the boric peroxide solution before placing it into any kind of applications, so that it will be lasting. So that's how you have a different treatment techniques for particularly natural fibers to increase its durability over a period of time.
Sir, one more question, sir. Which special concrete is effective for heavy moving loading structures like petrol bunks?
Yeah, particularly the concretes used in, because a lot of vehicles come and there is a lot of impact load and abrasion resistance. So the concrete you have to design such that using the fibers and using the special materials, wherein you have a more impact resistance, at the same time more abrasion resistance. That particular property should have the concrete, whatever you design. I can say the fiber reinforced concrete, specially designed for these applications.
Thank you, sir. I don't see any other questions or queries in the chat box.
1 minute, sir. One of your students, he was there in the BMS. He has joined and he wished also. I just missed this message. He was his student in BMS IT, it seems.
Okay, sir. Oh, okay, okay. Maybe I might.
Sir, one last question.
Yes, sir. Tell me.
May I,
Ajit,
sir?
tell me.
Yes, yes, sir, please.
Thank you.
Yes, sir. Yes, sir.
Nowadays, this white topping and concrete roads are becoming very common in every town and as well as in villages. And I have seen this top in particularly villages. This concrete road top is weathering out. Aggregates are getting exposed. The top binding material is getting weathered out. Now that's going to be a big, challenge for government to repair that. Can you just throw some light on this? Why this happens? And even though it is designed to take care of the weathering effects, but because of some poor workability or construction activity, contractors' poor work, this is seen. So how to address that and how can we avoid this?
Because the question itself has got the answer, because the quality issues are there, and to address, usually people go for the small kind of grouting and other things to restore, if there is, but it again depends on the kind of deterioration that happened or the kind of abrasion that happened. And a lot of quality issues are there because of the at some places, and some places people are doing very good. So wherever there is many governments, state governments having the quality task force, particularly if you take Karnataka state government, earlier Dr. C.S. Vishnath sir was handling the entire Karnataka State Task Force Committee on quality aspects of the buildings or the works. So similarly, the state governments has to form a task force committee of quality of particularly the public works. Very, very important. Some of the states are very active in that manner, and some states there are, because India is a country wherein we have a mix of all the people.
Yes, so one more question I can see in the chat box. It says, can we make bricks using bamboo fiber?
Yes, Samirji, yes, definitely we can use it. But we have to do a few experiments we conducted using a lot of students, a lot of researchers have done the bricks using coconut fiber and so on. Definitely using the bamboo fibers also you can make the bricks. Definitely it will arrest the crack behavior of the brick. That means you get a better brick when you add the fiber to it. So the experiments has to be conducted. Definitely, we can do that. When they are making the bricks using the fibers, coconut fibers, why not the bamboo fibers? I don't know, very limited applications, limited work that are done in this particular area. Definitely, we can do it. And I've seen, one of my students from BMS IT, yes, Sunil Tiwari. Thank you, Sunil, for attending the lecture.
Sir, Venkatesh Babu, sir.
Sir, I can't see Venkatesh Babu, sir, in the participant list.
He's there. Okay, you can conclude, sir, please.
Okay, sir. Okay. Now I would like to extend the vote of thanks. Firstly, I would like to thank Dr. Jagadish Vengala, sir, for enlightening us with the principal priceless knowledge about how normal concrete should be. He also talked about properties of concrete, enlightened us with the mineral admixtures, various tests on concrete, and he also talked about different types of concrete and their applications and properties. Thank you, sir. Thank you so much for giving us your time and enlightening us. Thank you, sir. Secondly, I would like to thank our management who gave us an opportunity to conduct such a quality webinar. Though our principal sir is absent today, I thank him for permitting us to conduct this webinar. I would also thank our beloved HOD sir, Dr. DL Venkatesh Babu sir, for addressing this webinar and supporting us in all aspects. I would also thank all the participants who have gathered here and helped us make this event a grand success. Not the least, but I'd also like to thank Mr. Sanat sir, who had been supportive to me since the very beginning of this seminar, as I am a fresher and I had a very little knowledge about this conduction and all. I thank Sanat sir for helping me out. Thank you one and all. Sir, can we conclude, sir?
Yes,
Yeah,
sir.
Once again, thanks to Department of Civil Engineering, particularly Dr. Venkatesh Babu sir and Sanat Kumar and the other faculty who is in Vinod, who is in touch with me. And I thank you all the participants for patiently. Thank you.
Thank you, Professor Jagadish. Once again, sorry because I was held up on some meeting, other meetings parallelly. Thank you, thank you once again for joining and spending your valuable time with us and sharing a lot of information. I hope all the participants are really enjoyed with your talk. Hope to see you offline so soon to take up some more seminars at college level. Thank you once again to all of you. Thank you. I'll thank the coordinator, Vinod also. I'll thank Sarath Kumar for coordinating entire program, and he is the in charge of webinar coordination. So far, we conducted almost 15 plus, another 3 webinars in line. I request all the participants to join for the webinar. Thank you, Professor. Thank you, Vinod, for coordinating. Thank you, Zanath. Thank you, Dr. Praveen, for joining today. Dr. V. Selvam. And we'll thank all the participants joined from different parts of the country. Thank you once again to all of you.
Thank you, sir. Thank you all, and I'm signing out.
Yes, sir. Yes, sir. I'm ending the meeting. Thank you.
Hello.
Thank you, sir. Thank you all.
Hello. I'm audible? Yeah. Srikanth, say something. Hello.